Chapter 11, Force and Pressure. Introduction. In the previous class, we learnt about the different ways in which things move. A pendulum shows periodic motion, a tennis ball shows curvilinear motion, and a fan shows circular motion. What makes all these objects move? Does a pendulum start moving on its own? To make things move or to stop moving things, we have to apply force. We apply force in different ways all the time. We also experience force all the time. Force. A force is generated when an object pushes or pulls another object. You move your body all the time, and in doing so, you are exerting force. You exert force when you bend, twist, push, pull, tear, or press anything.
In all the above activities, you push, pull, or press an object and hence apply force.
In all these activities, there is interaction between your hands and the object. To push or pull, you need to touch an object. Hence, we can say that force is exerted when there is interaction between two objects. What does force do? Now can you conclude what force can do to the objects?
Force changes the position of an object. You can make an object at rest move by applying force. Similarly, you can stop a moving object by applying force. For example, kicking a football at rest. Force changes the speed of an object. If you push a moving football, it starts moving faster. Force increases the speed of a moving object when applied in the direction of motion. Force changes the direction of a moving object. When a cricket batsman hits the ball coming towards him from the bowler, the ball goes off in another direction. Force can change the direction of a moving object. Force changes the shape of an object. If you squeeze a sponge, it becomes smaller. Similarly, when you press on wet stand, you create your footprint. Rolling of chapatis, making shapes from plasticine or clay, etc. are examples where force changes the shape of an object. Direction of force. The effects of force on a body depend upon two factors: the amount of force applied on the body, the direction in which the force is applied. You must have seen people pushing a bus to start it. They all push it from one side and the bus moves in the direction of the push. Now, imagine if half of the people were also pushing the bus from the opposite side with the same force. Will the bus move? It will not move because the force applied from opposite side cancels out. Whenever a force is applied to a body to change its position, speed or direction, the body moves in the direction of the force. When multiple forces are applied on a body towards the same side, they add up. While pushing a bus, force applied by all people add up. However, when two forces are applied from the opposite sides, they subtract and the net force acts in the direction of the larger force. If the two forces applied from opposite sides are equal, the net force will be zero. Thus, force acting on a body has a magnitude as well as a direction. The SI unit of force is Newton N, named after the famous physicist Sir Isaac Newton. Types of forces. As said above, a force is generated between two objects when they interact. This interaction can occur in different ways. Some interactions involve contact between the surfaces of objects, whereas others do not. Based on this, forces can be classified in two categories: contact forces, non-contact forces. Contact forces. A contact force is that which is generated when two surfaces are in contact with each other. There are two contact forces. Muscular force. It is the force applied by the muscles to do the work. Lifting of a suitcase, pulling water from a well, weightlifting, running, pulling of a cart by a horse or an ox are examples of actions done with the help of force exerted by muscles. Friction. When you kick a ball on ground, it stops moving after going some distance. This is due to frictional force. Friction is generated when two surfaces rub against each other. Friction always opposes motion. We will learn more about friction in the next chapter. Non-contact forces.
A non-contact force is that which is generated when two surfaces interact but are not in contact with each other.
There are three main non-contact forces. Gravitational force. Gravitational force is the attractive force existing between all material things. An object exerts the force of attraction on all other objects in the universe. However, the magnitude of this force depends on the mass of the object and its distance from other objects. A heavier object exerts more gravity than a lighter object. For us, the only important gravitational force is the gravity of the Earth. Due to its extremely high mass, gravitational force of the Earth is strong and pulls everything towards its center. The gravitational pull of the Earth is measured in terms of weight. Weight is defined as the force with which a body is pulled towards the center of the Earth. Weight of an object will be different at different places on Earth due to their varying distance from the Earth's center. The gravity of the Moon is about 1/6 of that of the Earth. This is because the Moon is 6 times lighter than the Earth. So, if an object weighs 60 Newton on Earth, it will weigh only 10 Newton on Moon. If the same object goes into the space where there is no gravity acting on it, it will be weightless. You must understand that it is the gravity that helps you move on the Earth's surface. It is gravity of the Sun that keeps all the planets in their orbits, and it is the gravity of Earth that keeps Moon in its orbit. Can you imagine what would happen if there was no gravity? Weight of an object is measured by a spring balance. It has a spring attached to a scale as shown in the picture. Greater the force, more is the spring stretched and higher is the weight.
Use a spring balance to find the weight of some common objects that you use.
Electrostatic force. When you rub a comb in your hair and then bring it near pieces of paper, they get attracted to the comb. This happens due to the electrostatic force developed between the comb and the paper. Electrostatic force of attraction is between two oppositely charged bodies, one of which is positively charged and the other is negatively charged. We will learn about this force in chapter 15. Magnetic force. When you bring an iron pin near a magnet, it gets stuck to the magnet. This happens due to the magnetic force exerted by the magnet. Magnets exert this force on some substances like iron, nickel, and cobalt. You already know that a magnet has two poles, North Pole and South Pole. When two magnets are brought near one another,
the like poles repel and unlike poles attract.
Pressure. Try to cut an apple with the help of a knife. Which side of the knife do you use to do this? Now try to cut the apple with the opposite side of a knife. Is it difficult? Why? How will you be able to push a board pin into the board? By pressing it with the center of your palm or by pressing it with your thumb? You can cut the apple with the sharp edge of the knife, and you cannot press a board pin into the board with your palm. This is because the sharp edge of the knife exerts more pressure on the apple and the thumb exerts more pressure on the board pin. Pressure is force applied per unit area. Pressure depends on the magnitude of the force and the area over which it is applied. In the above example, force applied on either side of the knife is same, but the area is lesser on the sharp edge than the blunt edge, so the pressure is more. Similarly, force applied on the board pin with the thumb is over a less area than with the palm, creating more pressure. Pressure can be calculated by the formula pressure P is equal to force F upon area A. The unit of pressure can be worked out from the units of force and area. P is equal to Newton upon meter square is equal to Pascal, or N upon m square is equal to PA. Hence, 1 PA is equal to 1 Newton per meter square. Pascal is the SI unit of pressure. The CGS unit of pressure is dyne upon centimeter square. A bigger unit of pressure is kilopascal. 1 kPa is equal to 1000 Pa.
Problem. A force of 1000 Newton is applied on an area of 5 meters square. Calculate the pressure exerted. Solution. Force applied is equal to 1000 Newton. Area of surface is equal to 5 meters square. Therefore, pressure is equal to force upon area. P is equal to 1000 Newton upon 5 meters square is equal to 200 Pascal. Pressure in our life. Like the examples mentioned above, there are many applications of pressure in our life. Walking with flat heel shoes is less painful than walking with the pencil heel shoes. You cannot walk with the pencil heel shoes on sand or soft ground. A nail with a pointed end is easily hammered into the wall than a nail with a blunt end. A heavy bag with narrow straps is more difficult to carry than a bag with wider straps. Apart from these examples, there is pressure exerted by air and the pressure exerted by a liquid. Let us learn more about these. Pressure due to air. Air is a mixture of gases. When the gas is enclosed in a container, its particles collide with the walls of the container. The force exerted by the collisions per unit area is called the pressure of the gas. You must have read that for a car to move properly, the tires should have adequate pressure. For this, air is filled into the tubes inside the tires. This air exerts pressure on the wall of the tube and the tire becomes hard. When this tube is pierced by a pointed object, the tire gets deflated and the car is not able to move. A gas always exerts pressure on the surface with which it is in contact. This is because the gas molecules are always moving. While moving, they collide with each other, as well as the surface of contact. Atmospheric pressure. The Earth is surrounded by a layer of air which is about 300 km thick. This air has a lot of weight which pushes down on the Earth's surface due to gravity. The pressure created by the weight of air is called atmospheric pressure. Since the particles of air move randomly in all directions, the atmospheric pressure acts in all directions. The air is most dense near the surface of the Earth. As we move higher up in the air, the density of air decreases. Can you guess why? Consequently, the atmospheric pressure is maximum on the surface of the Earth and decreases gradually as we up. This means pressure due to air will be much less at the top of Mount Everest than at the sea level. The pressure exerted by the atmosphere at the sea level is about 1,01,325 Pascal. This is also called as 1 atmosphere, 1 atm. 1 atmosphere is equal to 1,01,325 Pascal. The instrument used to measure atmospheric pressure is called a barometer. A barometer contains a column of mercury dipped in a container filled with mercury. At 1 atmosphere pressure, the height of the mercury column is 76 centimeter. Application of air pressure. Working of a dropper. A dropper is filled with a liquid by reducing the pressure inside it. When a dropper is dipped in a liquid and its rubber bulb pressed, the air inside the dropper tube is expelled into the liquid. This reduces the pressure inside the dropper. However, when the bulb is released, the atmospheric pressure acting on the surface of liquid pushes it inside the dropper. Remember, a gas or liquid always moves from a high pressure point to a low pressure point till the pressure at both points become equal. A syringe works on the same principle as the dropper. Our body is able to withstand the strong atmospheric pressure due to balancing the pressure of blood inside our body. In our body, the heart pumps blood into blood vessels at a pressure. The pressure exerted by the blood on the walls of the blood vessels is called blood pressure, and it is slightly higher than the atmospheric pressure. As a result, we do not feel the atmospheric pressure. When a person moves high up in the air or the mountains, the atmospheric pressure decreases a lot, but the blood pressure remains same. This may lead to nosebleeds due to rupturing of the blood vessels.
Pressure due to liquids. Like gases, liquids are also made up of moving particles. So, a liquid also exerts pressure on the walls of its container and any object that is put in it. Pressure in liquids also act in all directions.
When you walk in the water at a swimming pool or in the sea, you feel lighter. This is because of the pressure exerted by the liquid on you upwards. This is called upthrust. You will learn more about upthrust in higher classes. The above activity shows that we go deeper in water, the pressure increases. For this reason, the deep-sea divers wear special suits that protect their bodies from getting crushed by the pressure of water. Pressure in liquids is measured by a device called manometer.